Before that, let me say a couple of words about myself. Currently, I'm working as enterprise data scientist at Philip Morris International. My background is computer science. I'm also a best practices ambassador in my company, and I really enjoy motorbike trips and aviation. Yesterday, someone asked me a very important question. Why Philip Morris International, a little bit old-fashioned company that is selling cigarettes, is here on the AI conference? And it was a very important question and valid to some extension. And the truth is that currently we are under a huge transformation from a little bit old-fashioned company to the fully digital one. And we are right now focused mostly on our customers. And that's why we, during this transformation, we needed to bring data science into our company. And during the transformation, we faced a couple of challenges. One of them was how we can create reproducible models and push it into production. And actually, it was impossible to solve this problem, to somehow answer that question. Because what you can do, you can create data products and push it into production. It can be reproducible data products, not only models. And we start with, okay, but before that, let me explain you a little bit what data product is, actually. Data product is a software. This is very important. And it has AI or machine learning core inside. You have a data as an input. You have somehow transformed data as an output. And inside you have a machine learning core. And why we need data products in our company? In our company, we have more than 1,000 different IT solutions, and we need to somehow connect our new data products from the data scientist area into existing infrastructure. And this is really important. And we started shipping these data products, and we faced another challenge. Because we fall into the infinitive loop of sadness by Josh Wills from Slack, and it was really hard to working together with data engineers, DevOps, data scientists, solution architects, data management. It was really hard. But at the end, we used the Scrum framework. And thanks to that framework, we just go into one room, into a single room, all of us, like, of course, project specific. There was a DevOps, data engineer, of course, data scientist, and we were working usually together, and only together you can create the software. Because models you can create like by your own, but if you would like to create something bigger, data products, you need to bring more people to the table, and thanks to that you can create much bigger products. And also, it's not only that we are all Scrum certified. We have also, from some level we have some level of expertise in also different areas. For example, I am data scientist, but I have also a basic knowledge from data engineers part and DevOps part. And thanks to that, it also helping us to working closely and creating this kind of products. Okay, in October 2012, actually, I explain you what data product is and why we need data products in our company. And right now, I would like to show you how we are creating data products in Philip Morris International. And this story, I would like to start from the October 2012, when Thomas Davenport and DJ Patil, they wrote an article about the success job of the 21st century. And actually, I'm not sure if that is true, that it is the success job of the 21st century, right? But what I know is that in many companies, huge demand for the data scientist position started. And also on the universities, they created many courses about data science, many courses pop up in the internet. They claimed that you can master data science even in 1 month. Of course, you can try to do that. You probably know that it's pretty impossible. In 1 month, you can learn some basics, how to create models, and that's all. And after these courses, after the courses on the universities, data scientists end up with the perception that that machine learning code is actually the most important part in a data product. Here we have data product architecture, and the perception is that the machine learning code is pretty huge, right? But the reality is that machine learning code is pretty small part in the entire architecture. Here we have machine learning code. Also, students learned a little bit about data collection, data verification, some feature extraction, data cleaning, but only a part of that during studies. And we end up with the situation when, from one hand side, we have huge demand from the companies for data scientists, huge demand. And from the other hand side, we have many data scientists, but without proper knowledge how to create entire data product. They can create models, they can clean data, they can do feature engineering, but then they don't know how to create entire data products. And that's why many companies like Google, AWS, Microsoft, Dataiku, to name few, they invented machine learning as a service. And this is also very important idea, vision of these people. And it's really nice because using machine learning as a service, you can create data products without proper knowledge how to create data products, because everything is in the cloud and you can do it really fast. However, you don't have much control about the infrastructure, about what and how you would like to use at your company. And that's why in Philip Morris International we chose the third path, and we created our own platform, which is not only data storage, but it's also machine learning as a service platform for data scientists. And we have two things. We have easy of use for data scientists, and we have also the possibility to use it and to use infrastructure that we already have. And remember, we have more than 1,000 different IT solutions that, thanks to that, we can combine it to the existing infrastructure. And DataOcean actually is a little bit complicated. Like if we will go deeper, I have few slides after the presentation I can show you. However, here I would like to focus mostly on data products right now, and that's why here is pretty simple one. We have data as an input, then we have DataOcean, and transform data as an output. And let me focus on data products. And to create great data products, you need to have a vision how you would like to these products looks like at the end, right? You need to start from the vision. And we had a vision, and we created a workflow that is flexible, inspection-ready, reproducible, and easy to use. And based on that workflow, then we created data product architecture. And right now, I would like to create it with you. It was around, I don't know, 2 years of our work to create that. And let's create it together. We have Docker containers because we'd like to be this whole workflow flexible, right? We gain flexibility because we are using Docker containers. For the exploration phase, we have Jupyter notebooks. Then we are pushing code to the Python models. Of course, we are using HDFS from the Hadoop to store our data. We are inspection ready because we are using Bitbucket. This is a code repository system, like in GitHub. We have also JFrog Artifactory, which is scanned by Black Duck. And we have Kibana for monitoring. Really nice tool. Reproducibility. Of course, Docker containers, because you can reuse Docker containers from different hubs, from different data scientists, from different projects also, and Bitbucket code repository system. And everything needs to be easy to use for data scientists. We have Airflow for scheduling. We are using on-demand infrastructure from AWS, Jenkins for automation, Dash, which is open source. This is actually Python library for creating some visualizations application, Flask for creating APIs, and that's all. This is the infrastructure that we, as data scientists, we are using it. Okay, we had a vision, right? Right now, we already have this data product architecture that we are using, but we need something more, right? Because we have like a car, but without the steering wheel, right? We have something that we don't know how to drive it. And that's why we introduced our best practices, and we have Docker. We are using Docker containers, and we have best practices how to use that across entire company. This is very important. It was really hard to ensure that everyone will use the same best practices, right? CI/CD practices, code reviews, project templates, and we are testing the solutions. Also, we are exploring in notebooks. Then we are using Python models. We are using Python style guides. And today, I don't have time to explain all of them, but I think that I will focus on the most important part, which is here. And I would like to start from Docker containers. Docker containers are great. This is something that probably you already know, because you have freedom to install everything you want inside. It's very easy to do that. And as I said, this whole process, whole Docker, is reproducible. I can tell you from my experience, I was working for the project. It was similar to the project from guys from Tokyo. And I said, guys, let me reuse your Docker container, because I will do pretty similar job, right? And I reuse it. With some parts also, with some part of code also. It was like, I don't know, it was 1 week probably of my work. I save it because I reuse it. Perfect situation. Isolation, also at all I think software developers at the beginning have this problem that one software developer is using a different environment, for example, Python 2.7. Other software developer is using 3.5. And then, if you would like to integrate your code, it's a nightmare, right? Because also you can have different versions of the libraries, and then it's pretty hard to integrate the code. In Docker containers, you don't have this problem. And speed, very fast to implement, very fast to use, very great tool. Also, if we have more than 1,100 gigabytes of data, we have a special Docker container which is connected to our cluster. And then we can use it to analyze using Spark framework. Another very important topic, project templates. This is something that we took from the software developers. It's Cookiecutter. Why Cookiecutter? Because you would like to have template that will suit all your needs across the company. and we had the template. We also used the awesome process, which is very well known in the data science community. It's about obtaining, scrubbing, exploring, creating model, and about industrialization. And here, as you can see, we have Jupyter notebooks for the exploration phase, and then we have in source we have the same structure for the industrialization. It's really help us to. It's industrialization. Then is like one click. It's pretty easy. Very good concept. And the CI/CD for data science. I think that this part is the most important part. And I think that this quote is perfectly suits CI/CD practices. It's not the strongest of the species that survive, nor the most intelligent, but the one most responsive to change. Most responsive to change. This is the most important part. These words are from Charles Darwin. And really, in current world, in current environment, you need to be responsive to change. Because everything is going so fast that your software also needs to be responsive. And let me say a few words, like the basics, what CI/CD practices are. First of all, continuous integration. You need to integrate your code really often with your colleagues, because only then you will ensure that that you have like one version that is ready for production. And I like to say that you should exchange save button with commit. This is like you probably are doing save really often. You should do commit really often also. Continuous delivery. You need to have your code in a production, in a deploy-ready state all the time. Because let's imagine that your product owner came to you and he said, "Okay, Maciej, let's, we are finishing with this project. You have 1 day to do some MVP of that and to deliver to us something that is working, right? And I need to have something that is in the delivery ready state, right? Because only then I can really fast push it to the production or QA. And then continuous deployment. This is also very important because this is actually this act of pushing your changes to your customers. And as we know, customers are the most important, and they want from us the best application possible right now, right? If you are currently not doing that, let's start. And in our company, we have few phases of where we are using CI/CD practices, this process. We are starting from the business needs, because this is a very important part, right? Business needs. And then, at the end, what we have, we are generating value. Because this is the thing why companies have data science departments inside, right? That's why we have job. Because we can, as data scientists, we can generate value for them. And this is I think that's really good from this perspective. And of course, in between exploration phase, which we call alpha, then we have beta for automation. We are using some Jenkins jobs for that. And also in the beta phase, we are creating this data product. It can be a web application, for example. Then we push it to our testers. Testers can test it. And if everything is OK, we are we just industrialize this product. Then users can use it. And if you already have data products, then it's time for monitoring. And to do monitoring, currently we are using Kibana. This is from the Elk stack, and Airflow. And Kibana is a very nice tool. It's pretty simple to create a dashboard. This is like a sample dashboard I created for you. You can see that we have some how many users logged into the application, how many times they run the model, some warnings from the application. And this is very good from the monitoring perspective. And Airflow is a scheduler for the Python jobs, Bash jobs. To name few, you can do your pipelines, and then you can monitor these pipelines. This is really really cool if you are industrializing something, because then you know that, for example, one part is not working, and you need to quickly respond and quickly fix it. Right? This is the bugs fixing. And also to be all the time with the cutting edge technology, with something new, you need to be continuously technology scouting. And right now on our radar we have Kubernetes Sparkless, which is a very nice tool for monitoring Spark jobs. Then we have Binder. You can really quickly change your Git repository into the web application, let's say. Then ONNX, this is also nice. You have open source community, really big community for neural nets. MLflow, this is also for creating pipelines, but not for the jobs, but for the models and projects, machine learning models. Also nice. Actually, MLflow, we already have it almost in DataOcean. And Dask, which is a library similar to Pandas, but you can work in the distributed environment. Really nice. And also, we have something like best practices ambassador. And this is really cool because you can, having this kind of network, you can ensure that in your company, in your organization, everyone is using the same project templates, the same best practices, and members from this network, they are going to some trainings to train new data scientists across the world. And this is really nice because only then, at the end, we can learn from each other. We can also reuse their learnings, their products, their code. We have like one really strong community thanks to this kind of network. And to sum up, creating data products, creating a software generally, it's not easy task, as you probably know. And you need to learn how to play well with all parties involved, like data scientists, data engineers, and DevOps. And only then, together we can create better data products. And I hope that during this presentation, you learn something new. You can reuse it in your company. And thanks to that, all of us will create better and better products. Thank you very much.
Thank you very much. Теперь у нас есть возможность задать вопросы. У кого-то уже возник вопрос. Кто-то хочет что-то узнать. Есть.
Hi, thank you so
Hello.
much. Could you give an example of what you do in Philip Morris? What kind of models or do you use? What do you?
Yeah, what kind of use cases, right? Yeah, of course. I can give you a few examples. For example, we introduced a new device, which is IQOS. It's heat not burn technology. You're heating tobacco, not burning it. Really important. And you significantly reduced risk of using this device. And for example, we had a project about portfolio optimization, because we had a huge amount of our portfolio, like different types of Marlboro, different types of L&M, different kind of packages, different sizes, right? And in duty free on the airports, we didn't have space for new product, right? Like heats, which is the you are using heats in the IQOS, and that's why we optimized our portfolio. We delist some of the products that are currently not using by our customers, and we put our product. Also, we have also AI department, and they were working on the checking if actually on the shelves there are right products. They're using image recognition for that, and they can check it. Another example is, for example, we can forecast how many hits or IQOSes we should put into our supply chain to for our customers to have it ready in the shop. Okay, thanks.
Спасибо. Есть ли еще вопросы? Да, вижу.
Thanks for the presentation. I have a question regarding machine learning and artificial intelligence. Maybe it's a bit of a beginner question, but still. What will change if the product doesn't have machine learning, but there's something other technology that's related to artificial intelligence? Does it make...
Sorry, is related to?
Not related to machine learning.
Not.
Machine learning model. What will change in, for example, data architecture or in approaches that you take into designing that?
Mm-hmm. Thank you for that question. It's a good one. What can change in the infrastructure? I think that this infrastructure is pretty general. You can use it also for creating software. And what you, I think, don't need if you will not use machine learning models, I think you don't need the notebooks for the exploration phase. Because if you're creating models, machine learning models, you need to have this phase of exploration. Because it's not the easy answer that, okay, let's do some forecasting. Let's forecast how many apples a company will sell, right? And then it's not that easy that you can just use some model and everything will be fine. You need to have this exploration phase, and then during this phase, actually you are learning why people are using apples, first of all, and then you can, knowing the general idea about this field, you can predict something. This is important in machine learning.